One of your classmates have asked me to do a demonstration on how we would solve differential equations in Maple. I'm going to use problems from section 1 and see how Maple handles it. Now, Maple in and of itself isn't how you're supposed to get the solution, but Maple is something that you could use to check your solution once you had it. So if you were to turn in a chapter 1 test with only this answer on it, that would not be appropriate. Alright, so what I would do, the first problem I'm going to do is from section 2, problem number 5. So I'd go to Tools, Assistant, Ordinary Differential Equation Analyzer. So that's the tool that I would use. And then I'd edit the differential equation. I want it to be y in relationship to x, and I need a first order differential equation, and I need a 0th order differential equation. And then the problem says that y prime is equal to 1 divided by x plus 2 square root of. And I'd add that equation. And that's not what I put in the computer. So we'll see if we can get it into the computer better. Okay. Oh, and it's a square root of. Maybe I'll get it right. Who knows? No, still don't have it right. Well, I guess the only thing to do is to start over. One divided by x plus 2 raised to the .5 . Well, we finally got it right. Okay, and then we need a initial condition. Y at 2 is, or do we need an initial condition? Yes, we do, -1. Then we would solve it. I'm going to solve symbolically, tell it to solve. I have other things that could happen over there, but I'm probably not going to do it. So that's what Maple says the answer to this problem is. And If we're going to show the Maple commands, and then we'll copy and paste them into Maple. And so why would be that? Now, unless I went and, yeah, that's probably what it's supposed to be. So that was, let's see if I can do something clever. Chapter 1, Section 2, Problem 5. And then I'll do another one. And we're going to do Chapter 1, Section 4, Problem 13. And we're going to do the same thing. We're going to go the Tools, Assist, Ordinary Differential Equation Solver. Got to edit the differential equation. Okay. So we want y of x, and we want first order, and we want y of x 0th order 2 times. Okay, so I've got y of x times y of x cubed is equal to y of x raised to the 4th plus 1, parentheses there, and one back a little further, times cosine x. Well, that looks like the right problem. So I got y cubed dy dx is equal to y to the 4th plus 1 cosine x. Alright, so we're going to put that in. I have no initial condition, so I'm just going to solve it symbolically. So now I have what I would call an interesting solution. It's mathematically correct, but not one that we can handle because I've got imaginary numbers in it, and this is not a complex variable class. So obviously we should do this by separation of variables. That would work much better and come up with a better solution all the way around. But so I would not consider that solution to be okay for a yeah, there we go. Isn't that great? And why did it do it twice? That's why we're doing it twice. Again, I would not consider that a legitimate answer to this problem. Mainly because we have imaginary operators sitting there, we have imaginary operators sitting over here, and it says there's 1, 2, 3 solutions to the problem, and we all know that that's only going to have one lousy solution. So how would I do it if I wasn't going to use equation solver? Well, I probably wouldn't. Alright, so now we're going to look at one more, section number 6. So we're going to look at chapter 1, section 6, problem 30. So I'm going to go Tools, Assistance, Ordinary Differential Equation Solver, Edit Equations, and I'm going to have X parentheses. First of all, I'm going to put in a first derivative. Alright. I'm going to have parentheses x plus exponential exp y of x, close parentheses, times the first derivative equals x times exp minus y of x minus 1. And that must be right. Okay, so we're done entering it. We're going to solve it symbolically. I'm going to solve it. The limit says I have to have it done pretty quickly. And it looks like I have 2 solutions that are one with a plus and one with a minus. And why it's adding a second set of solutions for me, I have no idea. The C1 guy is my constant of integration that's there. Now I don't think I would leave it there. I would probably get rid of the natural logs and raise both sides of the equation as powers of e. That's probably what I would do, but I might leave it that way too. And now we're going to look at one more. I'm using a Shift T. No, I'm not. I'm using a Control T. A Control T to change it to text. Chapter 1, Section 8, Problem 8. And it's really Section 7, Problem 8. I would again go to the differential equation assistant tool, put in my equation, and I want x with respect to t, and I need a first order differential equation, and then it looks like I have two x's, so I'll insert two x's as well. Alright, so the derivative is supposed to be equal to 7 times x times parentheses x minus 13 close parentheses and yeah, that looks right. So we're done with entering the equation. We have to put an initial condition in. X at 0 is 17. And then I would solve it. And that looks pretty much like my answer. Now, again, on the test, if all you do is write down that answer, I'm just going to mark off 25 points because you didn't show your work, and the requirement is that you show your work. But there's no reason why you shouldn't know your answer so that when you get your answer, you can know to stop. So that's a reasonable thing to do as well. So for checking your work, Maple is a perfectly okay thing to do. All right, we'll probably do this one more or two more or three more times maybe. So when we get to the end of chapter 2, I'll do it again.